Hello, good morning. Today I'm going to be covering statistical skew. So first we're going to take some notes and then we'll follow it up with a bunch of examples. So here are the types of skew. First up on the list is normal skew, and this has a bell shape. This is data that is perfectly symmetrical and the mean is exactly at the peak. Here's what it can look like, and as you can see, it's perfectly symmetrical. If you were to fold it in half, all of this would overlap this other side, and here we have this bell shape. The next one is uniform skew. Here data is equally spread across the graphical display. Here's what it could potentially look like. The data seems uniformly spread, more or less. Now the next one is skewed to the left. Here this is data which has fewer observations on the left towards lower values. For example, here you can see that the data is skewed to the left, and you can kind of see a tail being formed on the left hand side. So this is skewed to the left. Skewed to the right, here the data has fewer observations on the right, so towards higher values. So here you can see again that we have a tail, this time on the right, and we have higher values here on the left. For skew to the left, it's the other way around. We have a tail on the left and the higher values are to the right. Lastly, we have bimodal skew, data with two different modes, basically two peaks. Here's an example of bimodal data. You can see that here there are two modes, two peaks that are the same, and these two same peaks are the highest ones. So here we have two different modes. These are basic representations of these kinds of skews. So now let's apply these definitions onto some examples. So let's take a look at example number 1. What do you notice about the following data? Determine the type of skew and explain your reasoning. As soon as we see the data, we can see that this histogram has one peak. So it has one mode. So it can't be bimodal, right? Because there's no two peaks. So this one's just one peak, and I'm going to give you another definition here. So we can say that this is unimodal. Unimodal has only one peak. Now we can see that the spread here, or the skewness here, it has a tail on the right, which means that this is skewed to the right. Skewed to the right. And now let's put this in a sentence. Here's my explanation. The data is unimodal because it only has one peak. This data is also skewed to the right because the observations are bigger on the left, and they get smaller as you approach the data on the left. So here, or I should say on the right, the bigger values are on the left, and then the data gets smaller as you move to the right. Cool. So let's try another example. So example 2, what do you notice about the following data? Determine the type of skew and explain your reasoning. Now here we can't say this is exactly symmetrical, because if we cut this in half, this right hand side is not going to overlap the left. It may not be symmetrical, but it seems like it's pretty uniformly spread out here. So here we can say that this data is uniform. Let's take a look at the peaks now, the modes. So here we can see that 85, 80, 75, and 70, they all share the same mode. They all share the highest peak together. So this is not unimodal because it doesn't have one mode. It actually has 4 of them. And remember, bimodal is only 2 highest peaks. Here we have more than 2. So when we have more than 2 modes, we say that this is multimodal. Multimodal. And now we can explain our reasoning with a sentence. Here's my explanation. The data is uniform. It is also multimodal because 4 different values tie having the biggest peak. And those 4 different values are 70, 75, 80, and 85. They all have the same highest frequency. Let's do one final example. So example 3, what do you notice about the following data? Determine the type of skew and explain your reasoning. Here we can see that if we cut this one in half, you can see that this side is going to overlap this side right here on the left. So here it is symmetrical. Symmetrical. We have a normal skew here, so this is normal. And here we can see that we only have one mode. So this is going to be unimodal. Unimodal. Only one mode. And if it's symmetrical, it's already established that it's only going to have exactly one peak. And here, well, we can still put that in our explanation. So let's go ahead and do that. And here's my explanation. The data is normal because it is symmetrical and it only has one peak, making it unimodal. Alright, so finish the assignment and I'll see you in the next lesson.